Good afternoon, everybody. So, thanks for the introduction, Mark. So, yeah, my name's Paul Davies. I'm with Boeing Research and Technology. I'm based in California, and BR&T, as we call it, Boeing Research and Technology, is a central kind of R&D organization that develops technology for both commercial and defense side of Boeing's businesses. So last year here in Munich, I think I introduced BARC. I may have given kind of a talk about some of the ROI studies we've done with the prototype of the system. So what I'd like to do this year is give you kind of some updates and show you some examples of where we're using it, and talk about, well, there'll be four main applications. And I've got some videos and some pictures and examples of some of them, and then I'll talk through some of the others. So I can start just by highlighting our team, which is growing, and we've gone kind of global. So they're in Southern California. That's where most of the group are located. I'm the project manager. That's where I sit, and some of the developers are here. Most of the developers are here. And then we have some developers now. Boeing's opened an office in Korea. It's called Boeing Korea Engineering Technology Center. So we have 2 developers over there who are now working full-time on BARC. And we have some support in the Seattle area. This is where most of our commercial manufacturing is done, and Charleston. And the green boxes are all the people inside the company that are utilizing the platform in some way. And so I'll talk mostly about wire install and locator and part install and how these are being used. And you can see kind of where in fact, all the major sites across the US are using it now. So this is kind of the top level view of the system, and I'll talk through kind of roughly how it works. So essentially we try to leverage existing 3D data that we already have for our programs. We don't want to author new step-by-step instructions for the most part. I'm talking very generally here. And so we've built, one of the issues with that is that we, Boeing, have different systems. A lot of different programs use different MES systems and use different CAD tools and things like that. We're not standardized yet. We're working toward that. So we've had to build interfaces from BARC to many of those to be able to ingest the 3D data that exists. So if I walk you through one of the use cases, we'll look at wiring installation. So the application is called BARC Wire Install, and it runs on a HoloLens. We have a prototype version on a Android phone and then a Windows 10 tablet. HoloLens is by far the most used device for BARC currently. And it will take data in the form of a Unity asset bundle from BARC services. And what BARC services generates that bundle and translates all the source data, makes the geometry lightweight and everything, and breaks it up by job and stages it in a cloud, in our own internal cloud for retrieval. And so I'll talk you through how it works, but BARC services gets its data from the production system, so we don't author any new content. It's all about reusing what is already there. And it's kind of similar flows for the other applications. Some are different, than others. And then more recently, we've just built this application updater that sits on the side, and it's able to manage the version of the applications that are on the HoloLens. So when we have new releases, new builds, we can update them remotely, and we can make sure they're all on the same version and everything like that. So that's kind of very top level what the system is. And you can see here some of the I've removed some of the specifics, but there's 4 MES systems we now talk to, and I think we can get data from maybe 5 3D repositories that different programs are using. So I'll walk through the applications. There's 4 main front-end. When I say front-end, I mean the client application that runs on a HoloLens or a tablet. There's 4 of those, and we've kind of modeled them around the use cases that we think are the most valuable in airplane manufacturing. And this has come from experience and just talking to the programs and learning the pain points in building an airplane. And one of the big ones that we started with is wire install. It's a really hard thing to do. It's complicated. Wires are flexible. Drawings are really hard to read. And so we built an app called Wire Install, and I'll show you a video of that. This is just roughly what it looks like here in one quick view of it. You can see all the green structure is the frame of the aircraft. And for this particular job, you can see all the wires that have to be installed, and then the orange wires are where they go. So we align this view very accurately to the aircraft so they can actually follow this as a routing aid. It can also do things like, look at a wire, just put your cursor over it, and this, we call it a call out, will come up and it'll show you which wires are part of that bundle. And you can imagine, how useful this would be. I'll show you some images of how complex the wiring can be, but we've done a lot of work on the tanker program, which is incredibly complex wire, and I'll show you some pictures of that. Next, we've got Locator or Bark Locator, and that is really for, the main use case has been fasteners in holes, like matching up the right type of fasteners with the right type of holes. We've actually got some new use cases that are coming out of it, but essentially you can generate a data file which just contains a bunch of XYZ coordinates, and then we've just built it's a pretty simple app. We built a menu around that will take that data file and then display these little color-coded pins at every coordinate. And all the pins are at different angles, you can see there, because the way we put it together, one hole could be part of 2 or 3 or 4 groups. And so the pins would kind of all point to the same hole. And you can match the color of the pin with the color on the menu down here. And again, I'll explain that in more detail later. The third one would be what we call part install, which you might think is similar to wire install because wiring is a part. But the data sources are so different, we decided to keep it as a separate app for now. And so this one, any firm part like a skin panel or even a paint decal, things like that, we would pull into part install. We have another, the defense side of Boeing has another way of delivering work instructions that we call MBI. It's a model-based instruction. We're actually integrating that capability into part install currently. So there are thousands of MBIs that exist, and when we're done, probably before the end of this year, you'll be able to view any of those existing MBIs in part install. And then finally, the 3D viewer app is much more kind of flexible and generic, and to be honest, it's not really intended for use in the factory. It allows the user to bring their own CAD data. It doesn't collect data from anywhere. It doesn't pull anything from any MES or PLM system. The user has to upload their own file, and then all it does is it will just process it, make it lightweight, and then again stage it and allow you to align it to something. So it might be for, say, an engineer wants to look at a concept design, or it might be he's trying to figure out an assembly process to see if there's any interferences or if something will fit. If he had a CAD model and maybe a mock-up or a partially built assembly, he could upload a model to 3D viewer and then just take it out to the factory and view it very quickly, and it would be aligned to the part. And actually, we just finished that application, 3D viewer, and our Korea team actually took the lead on that, on the back end and the front end, and we have the first version just been made available. And all of these applications now, the pictures that were on the previous slides should be updated. All of these applications now have the common user interface that we've just finished also. So we realized that someone who used, say, the wire install app, and then they pick up and they want to have a locator example or a part install, they shouldn't have to be retrained. They should know kind of the basics of how to use it. So we sat down, we took about a week, the team, and we involved some UX designers and some end users, and we sat down and we kind of plotted out what the UI should do so that it can cover all the functions of all the 4 applications, and it looks like this. So we call the middle part the work menu, and that is the same for every app. The buttons on it might be a little different depending on the use case, but the work menu is always there. And so when you when you log onto the HoloLens, first thing it shows you is the work menu. On the top there is always the alignment menu. So that's where we talk about how we position the CAD geometry and how we spatially align it to the plane. That's handled through 3 ways of aligning. We call it default alignment, which just puts it in front of you, so it doesn't actually really align it, it just lets you view it. Precision alignment is that middle button that lets you use a 3-point process that we're actually improving, and I'll tell you about that. And then persistent alignment uses spatial anchors so that once you've aligned it once, if you're on the same airplane, on the same HoloLens, you don't have to realign it. You can just click persistent. So that's always at the top, and then the other 3, the right hand, left hand, and the lower menu, those are all just kind of flexible, ad hoc, depending on the use case. So I can so for instance, for wiring, on the right-hand side would be all of your wires. There'd be all the wire lists, and you can scroll through it and turn them on and off individually. On the left-hand side would be something we call a production illustration zone. So we break up the aircraft into different zones, and you can select which zone you're in on the left, and that'll affect which wires you see on the right. And the bottom one we don't use in wire install. But so if I was coming to a, say, Bark Locator part install, it would look roughly similar. And again, the goal was so that the users, it's intuitive how they can switch between the apps. And this is probably actually the first kind of step toward integrating some of these apps. We kind of built them separately because usually we start with requirements from a program or a different use case, and they say how they want it done, so we build an MVP, and then we mature it. But what we're realizing more and more is that other than the data sources, which we can handle on the back end, a lot of the functions on the front end are the same. You're just turning views on and off, you're viewing labels, or you're not viewing labels, and Locator might be different, but some of the other ones we think we can converge, so that'll probably be more in next year's work that we start looking at that. So this is kind of the process that any user would follow for any of the applications. So I mentioned Bark Services, so that's the back end of the system that handles all the data translation. It also handles the security and the unlocking of the device. We got a lot of requirements from our information security group about who should see this type of data and where it has to reside and where it can't reside, maybe more importantly. So typically, this will be the workflow. So a lead or a shift lead would log on to Bark Services, and it uses our standard company-wide authentication scheme. We call it Web Single Sign-On, and it's based on a smart badge and a PIN. So you have to use your badge and your PIN, and then it will present you, if you say you want to make a wiring job, it will present you with a screen that looks like that. And I have it more detail in a sec. And what you'll do is you'll enter your installation plan number, and again, the IP installation plan, those are authored by the program MEs previously. Those are all in the MES system. So then you enter your IP, the line number of the aircraft you're going to complete that work on, and then you'll assign it to an electrician, in this case, an end user. So then that builds the job. We call it building the job, and that triggers the whole process that I'll explain. And then when the electrician comes in, he will put the HoloLens on his head, also go to a shared common workstation, log in with his badge and his PIN, and then it knows that he is an electrician, and it will just present him with a QR code like that. And so with the HoloLens, he scans the QR code, and it will unlock the app. And then once the app's unlocked, it'll download all the jobs that have been assigned to him onto the device, and then he can actually, if he needs to, he can disconnect from the Wi-Fi at that point, and then walk out into the factory and perform the task. To align it to the aircraft, we have this precision alignment tool, again, which I'll elaborate on. And then you can see one or two of those example views of what it looks like on the plane. A couple of features that are in all the applications, kind of like a screensaver. If you put the HoloLens down and it doesn't move within a certain tolerance we've set, for, I believe it's 3 or 5 minutes, the app will lock, and then you'll need a PIN to unlock it. And that's just to prevent anyone leaving the device around that may have proprietary data on it or something, and somebody else picking it up. So that's built into all of them. And then another thing is when the user starts walking above a certain speed, the display will go blank so that there's no risk of distraction while they're walking through maybe a potentially hazardous environment. And as soon as you stop walking, it just comes right back on again. So we just do that. Both of those are just through using the pose of the device, which we just calculate whether it's still or moving too fast. So a really important, a really important topic for us is maintaining the configuration of the data and keeping control of the different versions. When the person, we need a complete, absolute trusted link between the person sitting designing the plane and the person who's putting it together. So, between those two, there's many stages where the data gets translated, though, and so we've built this in a way that anytime a change occurs from the designer, that will propagate through, and the next time it's viewed on the HoloLens, he'll see the latest change. We have a number of checks we've put in place to make sure that's the case. But in this case, say in the case of wiring, it's designed in CATIA. And then we use SAP Veg for data translation, the Visual Enterprise Generator. And then we have a service called the Bark Bundle Builder, which takes the output of Veg and then builds a Unity asset bundle out of it. And then stages it in, like I mentioned, it's an S3 storage, and then the HoloLens will download it. The asset bundle will time out and expire after a preset time. It's by program. So some programs say 24 hours, some say 2 days, whatever. So if you build a job, at 9 o'clock on Monday, and you try to view it, 9 o'clock on Wednesday, it will have expired, and the HoloLens won't even allow you to view it because it's marked as expired. And so you have to go rebuild it, and by rebuilding it, it's going to pull all the data again, so make sure you have the latest. So it's kind of like printing out a drawing. After 24 hours, the drawing that's no longer valid. Same way, but just in a digital way here. So here's a couple of pictures of some of the challenges we have. This is the 767 2C tanker aircraft, and it's one of the most complex in terms of wiring that we build. And you can see here, these are real life images. Taking a drawing like this, which I've had to blur a little bit, but you can kind of see, how difficult that could be to read, and relating that and interpreting it to in the environment you're in. And in some cases, you can't stand up; it's not high enough, and you're trying to work above your head or below your feet. It's really difficult. And so this was the first problem we actually tried to solve with Bark Wire, and I may have shown this picture last year. So what the approach we've taken is breaking up the data into more manageable chunks, so you don't need everything on that drawing to complete the job. So Spark services will break up the data and then present it in a way that's spatially aligned to the aircraft. So you don't have to, interpret the drawing. You just put the HoloLens on and you see it. So this is the more detail on the workflow. So this is the back end of Bark Wire, and I mentioned how a job gets built. So a person would log in, and then this is how you build your jobs. Click on Make Kit. You enter your installation plan here, and just to give you an idea, there's probably 3,000 to 4,000 installation plans to build a tanker, maybe more, just for the wiring only. So you would enter any one of those IPs here, the line number. These are all the users here. So you would select which electrician is going to do it, and then you would pick a set of alignment points here. And these are all predetermined based on the zone. Remember I said the aircraft were divided up into zones. Each zone has one or more set of alignment points that have been predetermined. So based on the job and the zone, you pick one or more of these alignment point sets, and then you just hit Generate Kit, and that triggers the whole process. And what it does is it enters a job into the job table, and then we have the various services, like we have an artifact gatherer that will go and get the BOM, the 3D models, everything else needed, the wire list. And then it'll pass it to what's called the bundle builder, which takes all that information, makes a Unity bundle out of it, and stages it. The whole process can take anywhere from 3 to 10 minutes, depending on the size of the geometry. And the idea is that this will be done maybe the shift before or the night before. You can do it right before the job, but then you're just waiting for it to complete before you can go to work. So we encourage everyone to get their jobs built, maybe the shift before they're going to be worked. But of course, we know, we have a schedule of when each job's going to be worked, so that's not really an issue. And then once the jobs are complete, the admins can monitor this here, and it'll show complete. Sometimes they fail. Failures can be a number of reasons. It's usually not the Bark's fault, to be honest with you. It's usually a model is missing, or an IP is missing a BOM, or some bounding box was not entered correctly or something. And so occasionally we see a failure, and when that happens, the dev team get a notification by email, and so we can go in and make sure there's not actually a problem with Bark and it's some other issue that caused the failure. And then when the electrician logs in, they get this QR code, and I should mention, so each code is only valid for a certain amount of time. This code is embedded in there is a unlock token that's encrypted, and that's generated from Bark services at the request. So every time you hit either generate new code or you come to the screen, it requests a new unlock code. It's only valid for a minute, and the reason we do that is so that people can't print this out and leave it lying around, allowing anyone who can get a HoloLens to view the data. So by badging in and using your PIN, you've got 60 seconds after you click here to unlock the HoloLens. And if you miss it, you just generate a new code and you get another one. So when the device is unlocked, like I said, it'll download all the jobs that have been assigned to that person. So if for a shift, it could be 3 or 4, maybe 5. And it'll show them a list of all the IPs they've got to work, and then they'll select the one they want to start with, and it'll start working. This is the alignment process I mentioned. So we have this 3D printed tool, and we pick 3 predetermined points on the plane. That's one of them right there. And you just click as you go through 1, 2, 3. And then that actually it constructs a coordinate frame, and it aligns the HoloLens spatial map to the aircraft coordinate frame. So anytime we show a model from that point, it's aligned. And I need to pick up the pace just a little bit. So the view on the right is the scene that the user will see. And this is a short video. One of our electricians actually using it. We made a promotional video out of this earlier this year. And this is what it looks like, first-person view from wearing it. So you get the idea. This is the whole production illustration zone. And then by picking one particular IP, the Bark will filter the view and show you only the wires that are part of it. And then from there, in the latest version, you can actually just then isolate down to one exact wire. And you'll just see for that wire which clamps it goes through, which holes, how it has to be installed. It's very easy to follow. And so they just picked an IP, and you can see all the rest of the wires are gone, and it's only showing them that are ones that are there. And again, really important to understand that none of this data was touched by hand or generated specifically for the HoloLens. It was all reused from the existing CAD and PLM and MES systems. And this is the last slide, so I just want to touch on one of the other use cases, and that's what we call Locator. So I mentioned about matching up holes and fasteners. So it's actually been a really popular use case. I guess we drill a lot of holes and use a lot of fasteners. So this particular case is on one of the commercial airplane wings, and you can see here there's an automated driller that goes up and down in 6 phases and drills holes in the wing. And between each phase, these temporary fasteners need to be reconfigured and to make sure that there's enough, clamping to the structure beneath it. And but the most importantly, that we're not going to try and drill through a temporary fastener. If it's going to drill here, you can't have a temporary fastener. So what we do, for each phase, we've got the data. We just exported the data from the NC programming for this driller. And for phase, we show where all the fasteners should be using Locator, and it just reads them in. And you can see here, here's an example. There should not be a fastener there, but there is. So they would do a manual check before we deployed Bark here, and it would take them, I think, several hours. And now they do the check in about 5 to 10 minutes. They walk around the wing, just scan with the HoloLens. They make sure wherever the fasteners are, there's a dot. And in this case, that one would have been removed before the driller came along. Other use cases for Locator, lots have popped up around locating paint decals, showing where paint stickers, maintenance markings need to go. Stringer clips on the inside of the fuselage. Stringer is it's a piece of metal, I guess, that runs the length of the fuselage, and we put plastic clips on them, hundreds of them, in every airplane, and they used to attach wiring and other parts of the plane, blankets and things. Getting those in the right place is critical, because if you put them in the wrong place and then down the line somebody tries to install a bundle, there's no clip to attach it to. So we've gotten use cases now where we're showing all these stringer clips using Locator as well. So we think this one's going to become pretty popular. And then I just got back from Everett from our paint hangar, and we just completed a demo actually using part install to show decal locations. So on a 787, there's I think 200 to 300 decals, which could be like little maintenance markings or no-step labels or things like that. And getting them all on in the right place, oriented correctly, is can be challenging. So we now have an application where you put the HoloLens on, and it'll pull all the data from the existing systems. In this case, it's Velocity. It'll pull all the decal geometry out, and it will then align it and show it to the person both installing and inspecting. So that's our latest use case. It would be the paint decal, but I don't have any images of that, but I can share some offline. I think that's about all I got time for. I guess I have a video of Locator here. So I guess I'll just quickly show you. Yeah, so now on the left, it's got all the alignment zones, and then you can break up your data for Locator in different groupings, and then by picking the grouping, as I explained earlier, it'll allocate it a color, and then the little flag note, the little flag will display, and the color will match. There we go. So depending on your selections on the menu here, all the green ones are part of this group, and you can kind of match them up. So pretty simple app. Okay, thank you.
Perfect. Thank you very much, Paul.